In this lesson, we'll continue our work with inequalities to explore absolute value inequalities. Let's start with equations involving absolute value. So first off, if I tell you that the absolute value of z is equal to some number c, what does that tell us? So just as a very concrete example, suppose we have that the absolute value of z is equal to 7. What can that mean about z? Well, this tells us that z would be either equal to 7 or negative 7. So 7 and negative 7 are both values of z which have absolute value of 7. So you can think of absolute value as measuring the distance on the number line of a number to 0. So if I want the absolute value of z to be equal to c, that means I can be either out at plus c or at minus c. So these are the two values of z for which the absolute value of z is equal to c. Or to summarize, absolute value of z equals c tells us that z is plus or minus c. Now what about if I want the absolute value of z to be less than c? And again, if you want to think of a concrete example, what would it mean for the absolute value of z to be less than 7? So for the absolute value of z to be less than 7, well, we know that the absolute value of z is equal to c whenever we're at minus c or at c. So if I want the absolute value to be less than c, or the distance from 0 to be less than c, I need to be in between minus c and c. And we won't include the endpoints because we have a strictly less than here. Or if you want the absolute value of z to be less than 7, then you would need your z to be in between minus 7 and 7. So numbers like 0, 1, 2, -1, -2, a half, pi, minus pi, etc. would all satisfy this. So again, to summarize, absolute value of z less than c tells us that the expression z needs to be in between minus c and c. And I think you can see right away that if we do the same thing with less than or equal to, we'll have the same type of expression. We'll just have less than or equal to's instead of strictly less than. So z would need to be in between minus c and c, but this time we would include those endpoints plus or minus c. What about greater than? So to be greater than c, again, I know that the absolute value of z is equal to c whenever I'm at minus c or c. So for the absolute value or the distance from 0 to be greater than c, I need to be to the right of c or to the left of negative c. And again, if you want to think about a concrete example, if I say absolute value of z strictly greater than 7, then you know for sure any number that is greater than 7 will work. So 10, 15 and a half, etc. But also any number less than -7 will also work. So -10, -15 and a half, etc. These numbers also satisfy absolute value of z greater than 7. So to summarize, if the absolute value of z is greater than c, we need z to be bigger than c or less than minus c. And finally, just like with our third inequality, if I replace this with greater than or equal to, it's the same form of expression, simply with greater than or equal to c and less than or equal to minus c in the place of the greater than and less than symbols. Let's use this to solve an inequality. So I want the absolute value of 8x plus 3 to be less than 12. So going back to my summary, so my expression z is this 8x plus 3. So I want my absolute value of 8x plus 3 to be less than 12. So again, if I think about on a number line, so I've got 0, and then I have my 12 and -12. So we want our expression, which in this case is 8x plus 3, to be in between -12 and 12. So I'll rewrite this as -12 less than 8x plus 3 less than 12. Notice that I'm using strict less than symbols rather than less than or equal to. I'm not including the endpoints because our given inequality was of that form. I'll now subtract 3 from all sides of our inequality. So I get minus 15 less than 8x less than 12 minus 3 gives us 9. The next thing I'll do is divide all sides of our inequality by 8. Notice that the number 8 is positive so that the signs of our inequalities do not change. So I get negative 15 over 8 less than x less than 9 over 8. So the solution of our inequality absolute value 8x plus 3 less than 12 is x in between negative 15/8 and 9/8. And if you prefer to write this in interval notation, we get minus 15 over 8 to 9 over 8. And notice that I'm not including the endpoints because we have strict less than inequalities here.